Question 1. A car is initially at rest on a straight horizontal road. The car then accelerates along the road with a constant acceleration. So constant acceleration, that means we can use that, of 3.2 meters per second squared. Find the speed of the car after 5 seconds. So we have SUVAT, S-U-V-A-T. So we know the it's initially at rest. Initial velocity is 0. Acceleration, 3.2 meters per second. And we want the speed after 5 seconds. So t is 5. And we want to work out v, the velocity after 5 seconds. So it's v equals u plus at. So v is equal to 0 plus 3.2 times 5. 3.2 times 5 is going to be 16. So the speed is 16 meters per second. Part B, we want the distance travelled in the first 5 seconds. So this time we're working out S. We can use S equals ut plus half at squared. So it is equal to u times t, 0 times 5, plus half of a, which is 3.2, times t squared, which is 5 squared. And we can just type that into the calculator. So 0 times 5 is 0. So we just want half times 3.2 times 5 squared. And we get 40. So that is 40 meters. Question 2. A particle P has a mass of 5 kilograms. The particle is pulled along a rough, so friction, horizontal plane by a horizontal force with magnitude 28. We can see that in the diagram. The only resistance to motion is a frictional force of magnitude F newtons as shown in figure 1. Part A, find the magnitude of the normal reaction of the plane on P. So we've got a normal reaction which is perpendicular to the plane, and acting down we've got mg. So its weight is mass times gravity, so 5g. Because forces up equal forces down, we can say R is 5g. So R equals 5g. The particle is accelerating along the plane at 1.4 meters per second squared. 1.4 meters per second squared. So we're going to use F equals ma. Find the value of F, find the frictional force. So F equals ma. So the resultant force, F, so I mean, in this case, F is the resultant force. 28 take away F, where F means friction. I'm going to use FR for friction. Equals ma, which is 5 times the acceleration, which is 1.4. So to get friction by itself, I'm going to add friction to both sides and then take away 5 1.4s. The friction is 28, take away 5 1.4s, which is 21. So 21 newtons. The coefficient of friction between P and the plane is mu. Find the value of mu, give your answer to two significant figures. So friction is equal to mu times r. The maximum friction is mu times r, but because it's accelerating, we know that friction is taking its maximum value. So it's mu times r, so 21 equals mu times 5g. So mu is 21 over 5g. over 5 times 9.8, 3/7 of 0.43. At time t seconds, where t is greater or equal to 0, a particle p has velocity v meters per second, where v is t squared minus 3t plus 7i plus 2t squared minus 3j. Find the speed at time t equals 0. So when t equals 0, the velocity is going to be, when t is 0, we've just got 7i, and we've just got minus 3j. That's velocity. We want speed. So it's the magnitude, it's the Pythagoras. So speed is the square root of 7 squared plus 3 squared. Square root of 7 squared plus 3 squared is root 58, or 7.6. So I'll put 7.6 meters per second. Part B. Find the value of t when p is moving parallel to I plus j. So some multiple of I plus j. So t squared minus 3t plus 7i plus 2t squared minus 3j is equal to some multiple, so k times I plus j, or ki plus kj. So now I can write these into equations, one for the i's, one for the j's. So I can say t squared minus 3t plus 7 equals k for the i's, and 2t squared minus 3 is also equal k for the j's. And because they're equal, because they're both equal to k, we can put them equal to each other. So the I and the j is going to have to be the same. So I can write t squared minus 3t plus 7 equals 2t squared minus 3. Make it equal to 0 and solve. So take away t squared from both sides, add 3t to both sides, and take away 7 from both sides. And this is a quadratic that factorizes. It's plus 5 minus 2. So t is negative 5, which we can't have. T's got to be greater than 0, or t is 2. So t is 2. We want the acceleration now. So acceleration, part C. Acceleration is dv dt, the change of velocity with respect to time. So we need to differentiate. So times by the power, take 1 off the power. So times by the power, so I can see here I've got my original. Times by the power, take 1 off the power. So 2t minus 3i plus 4tj. So that's my acceleration. I want acceleration at t seconds, so that is my answer. Part D, find the value of t when the direction of the acceleration is perpendicular to I. So if it's I is in the direction of the x-axis, so this is the direction I. If it's perpendicular to I, that means it's moving in the j direction. So the i's equals 0, it's only got a j component. So if the I equals 0, 2t minus 3 is 0. T is 3 over 2. Question 4. A particle P is moving on a smooth horizontal plane. The particle has constant acceleration, 2I plus j meters per second squared. At time t equals 0, P passes through A. At time t equals 5, P passes through B. The velocity of P as it passes through A is negative 16I minus 3j meters per second. Find the speed of P as it passes through B. So we've got constant acceleration. So we've got suvat. So we are 5 seconds. Velocity originally is negative 16I minus 3j. We have constant acceleration, 2.4I plus j. And we want to know, well, let's find the velocity, and then we can use Pythagoras to find the speed. So v equals u plus at. V equals u, and I'm going to write these as columns. So negative 16, negative 3. V equals u plus a times t, 5 times 2.4, 1. So we have v equals negative 16, negative 3, plus 5 2.4s is 12, 5 ones are 5. So we have negative 16 plus 12, which is negative 4. Negative 3 plus 5 is 2. So we've got negative 4i plus 2j. And so the speed is the square root of 4 squared plus 2 squared. So we've got 2 root 5 or 4.5. So 4.5 meters per second. The position vector of A is 44i minus 10j meters. At time t equals t, where t is greater than 5, P passes through C. The position vector of C is 4i plus cj. So we can work out from that the displacement, how far has it moved. So the displacement is the new position, take away the old position. So 4c, take away 44 negative 10, which is negative 40, c plus 10. So that is our displacement. So we can put this into a new suvat, S-U-V-A-T. So its displacement is negative 40 I and c plus 10j. So we know A, so we know we've got constant acceleration, an initial velocity that we still know from before. So negative 16i minus 3j. And the acceleration was 2.4i minus j plus j, 2.4i plus j. And we want to know t. So S equals ut plus half at squared. S equals ut plus half at squared. And we're going to have to split this up into i's and j's. So just for i's only. S equals ut plus half at squared, just for i's. So the displacement is negative 40. And that is equal to ut, so negative 16t, plus half at squared, half times 2.4 times t squared. So we've got a quadratic, we'll make it equal to 0. So we have 1.2t squared minus 16t plus 40 equals 0. And we will just type it into the calculator to solve the quadratic. 1.2 negative 16 40. So we get 10 or 10/3. And t had to be bigger than 5, so we can reject 10/3, so t is 10. And find the value of c, so doing the same thing, but for the j's now. So for the j component, again, we are going to use s equals ut plus half at squared. This time we know t, so c plus 10 equals negative 3 times 10. S equals ut plus half. A for the j's is 1 times 10 squared. So c plus 10 equals negative 30 plus half of 150. So c plus 10 is 20. C is 10. Question 5. A small ball is projected with speed 28 meters per second from point O on horizontal ground. After moving for t seconds, the ball passes through the point A. So we're going to be splitting this up. Is there any other information we need? So we know where A is, 40 meters horizontally, 20 meters vertically. The motion of O to A is modelled as a particle moving freely under gravity. So for the vertical component, the acceleration is going to be a negative g. For the horizontal component, there's no acceleration. And the ball is projected at angle alpha, so we know that. So we're going to split this up into a horizontal motion and a vertical motion, and we're going to do SU that for both of them. And then we're going to show that t equals 10 over 7 cos alpha. So for the horizontal motion, SUVAT. So horizontally, the displacement was 40 and the initial was 28 cos alpha. So the horizontal component, 28 cos alpha, the vertical 28 sine alpha. So S is 40, U is 28 cos alpha. We don't know the final velocity. We know the acceleration horizontally is nothing, and t is t. That's what we're working out. But it'll be the same for the vertical part. So t will also be t for the vertical part. The acceleration is due to gravity, negative g. We don't know the final velocity. Our initial is 28 sine alpha for our vertical component, and its displacement was 20 meters. So for our horizontal component, that's the easiest one to work with. We can do S equals ut plus half at squared. and A is 0. So it's just S equals UT. So 40 equals 28 cos alpha times T. To get T by itself, divide by 28 cos alpha. And is that what we wanted? We just need to simplify it, I think. 10 over 7. Yep, divide top and bottom by 4. And that is our part A. For part B, show that tan squared alpha minus 4 tan alpha plus 3 equals 0. So we're going to do the same for the vertical component, and then we're going to eliminate T. So the vertical component, again, S equals UT plus half AT squared. 20 equals 28 sine alpha times T plus half minus GT squared. We're going to have to change our G. We'll change it into a 9.8. And then we're just going to eliminate T. So eliminating T, we get 20 equals 28 sine alpha times 10 over 7 cos alpha. And that's up to minus, moving the minus to the front, half of 9.8 times T squared, which is 10 over 7 cos alpha squared. So we're just going to simplify here. So we've got 20 equals, so 28 over 7 is 4 times 10 is 40. Sine alpha over cos alpha is tan alpha. Half of 9.8, let's use the calculator. So half of 9.8 times 10 over 7 squared is 10. So it's minus 10 over cos squared alpha. So we need to get rid of our cos squared alpha. And we're going to use our identities. So 1 over cos squared alpha, I'll write this in a different colour. 1 over cos squared alpha, I can change into sec squared alpha. And then, so it's cos squared alpha plus sine squared alpha, I should really be remembering this, equals 1. If I divide through by cos, I get 1 plus tan squared alpha equals sec squared alpha. So I can change 1 over cos squared alpha into 1 plus tan squared alpha. So I'm changing it into sec. I'm having 20 equals 40 tan alpha minus 10 sec squared alpha. And then changing sec squared alpha into 1 plus tan squared alpha. So 20 equals 40 tan alpha minus 10 times 1 plus tan squared alpha. And then we'll divide through by 10, make it equal to 0. And we should be done. So we've got tan squared alpha minus 4 tan alpha plus 3 equals 0. Was that what we wanted? Minus 4 plus 3. Yep, that's what we wanted. Find the greatest possible height in meters of the ball above the ground as the ball moves from O to A. So the greatest possible height. So when we're up here, that's when our velocity of our vertical component equals 0. So it's got no velocity for our vertical component at that stage. So let's start by finding out what alpha is. So I'm just going to use the calculator to solve the quadratic. So 1, -4, 3. I mean, I shouldn't really need the calculator there. So we've got 3 and 1. Tan alpha equals 3. Tan alpha equals 1. So we'll shift tan both of them. Shift tan 1 is 45. And shift tan 3 is 71.6. I can't see a reason to eliminate either of them. So we've got two possible values here for alpha. We want to find the greatest height. That's when the vertical component has got a velocity of 0. So we've got So we want to work out the greatest possible height. So that's the displacement vertically. We know its initial was 28 sine alpha. 28 sine alpha. Its velocity is 0 at its greatest height. And its acceleration is -g. So let's do v squared equals u squared plus 2as. V squared equals u squared plus 2as. So we've got 0 equals u squared, 28 sine. I'm going to take the larger value of alpha. If we're throwing it up at more of an angle, it should reach a greater height. So 28, so u squared plus 2 times minus 9.8 times s. So I've got the answer in the calculator. So 28 sine answer squared, 705.6. I've got 705.6. And I'll bring the two 9.8s over to the other side. So that would be 19.6s. Divide by 19.6. And we get 36. So 36 meters. The model does not include air resistance. State one other limitation of the model. So we can go with any of the assumptions that have been made. So we've used g as 9.8. We could use a more accurate g. We've modeled it as a particle. And we could say something about the wind. So I'll just say we could use a more accurate value for g. Question 6. A rod AB has a mass m and a length 2a. The rod has its end at A on a rough, so friction, horizontal ground. And its end at B against a smooth, no friction, vertical wall. we've got an angle theta with the ground, and it's in limiting equilibrium, which means friction is going to take its maximum value. Doesn't say if it's uniform or anything. State the direction, left or right, on figure 3 of the frictional force. So it is a uniform rod, that says further down. So we've got the weight, which is mg. We have a normal reaction at B, a normal reaction at A, and a friction force. So the friction force has to be acting in this direction to the right in order for these forces to be balanced. The forces to the left has to equal the forces to the right. So the friction force is opposing the motion, so it's going to slide to the left. So friction must be going to the right. So state a direction, left or right? The answer is right. So the friction has to oppose the motion. And we could say there is a force acting to the left. So to balance, friction must be to the right. Okay, so the rod is modelled as being uniform by taking moments about A. Show that S is the normal reaction at B. So this force here is called S. So we're going to take moments about A. The length is 2A. So we've got an A on both sides of the weight. So take moments about A and show that this. So let's get these angles right here. So theta will be there and there. So when we're taking our moments, it's going to be how far it is away from the point we're taking moments. So the distance times the perpendicular force. So the force acting perpendicular to our rod. So moments about A. So moments about A. Our clockwise moments must equal our anti-clockwise moments. So our clockwise moments, so it's the length times the perpendicular force. So it's A times mg cos theta. So that's the perpendicular force. That's the only clockwise moment. There's only one anti-clockwise moment as well. So 2A times S sine theta. Then we can divide both sides by A. Divide both sides by A. So we've got mg cos theta equals 2S sine theta. If we do divide both sides by sine theta, cos over sine is cot. So mg cot theta equals 2S, and half both sides. Half mg cot theta is equal to S. The coefficient of friction between the rod and the ground is mu. Given that tan theta is 3/4, find the value of mu. So friction is equal to mu times R. So we can have forces left equal forces right. So friction is equal to half mg cot theta, which is our S. We know tan theta is 3/4, so cot theta is 4/3. So it's mu R is half mg times 4/3, which is mu R equals half of 4/3 is 2/3, 2/3 mg. Then we can also do forces up equal forces down and say that the reaction at A is mg. So it's mu times mg equals 2/3 of mg. And then let's just divide both sides by mg, and mu is equal to 2/3. Find in terms of m and g the magnitude of the resultant force acting on the rod at A. So the magnitude of the resultant force at A, so we've got the reaction at A and we've got the friction force, which is mu times the reaction at A. So forces up equal forces down. So the reaction at A is mg. So the reaction at A is equal to mg. And the friction force is equal to mu, which is 2/3, times R, which is 2/3 mg. So we want to know the resultant force. So we've got a force acting, we've got two forces. So we've got a friction force acting this way of 2/3 mg. We've got the normal reaction of mg, and we want the resultant force. So that's like the hypotenuse. So we can use Pythagoras. So we can say a squared plus b squared equals c squared. So 2/3 mg squared plus mg squared equals the resultant force squared. So we've got, I could have just done this without mg and added the mg back afterwards, which I think I'm going to do. So let's have 2/3 squared plus 1 squared equals c squared. So it's the square root of 2/3 squared plus 1 squared. So the square root of 2/3 squared plus 1 squared is root 13/3. So it's square root 13/3. So in terms of mg, square root 13/3 mg newtons. In a new model, the rod is modelled as being non-uniform, with its centre of mass closer to B than it is to A. A new value of S is calculated using the new model, State whether this new value of S is larger, smaller, or equal to the value of S would take in the initial model. Give a reason for your answer. So in the new model, we're moving the weight further up. Moving the weight further up, so it's going to be closer to B. And what happens? So when we found S in part B, when we took moments about A, if we increased this number to make it bigger than A, we would have had a bigger answer. So if we had 1.5 A, we would have ended up with 3/4 mg cot theta. So the closer we make it to A, the bigger the normal reaction is going to be. So it would have to be larger. Larger, is that the word used in the question? The value of S would have to be larger. When taking moments about A, the weight, which is the clockwise moment, would be, so not the moment of the weight, not the weight. So let's switch this around. So it's the clockwise moment in brackets the weight would be larger, therefore S would need to be larger.